Hi everyone, welcome to Calculus 1. Today let's talk about the first session, 1.1, review of function. Here is the definition. A function f is a rule that assigns to each element x in a set A exactly one element. We call f of x. So function is like a machine. And we have some inputs, and we call the input x. And we have some outputs, and we call the output y. So output is f add on x. Okay? And the graph is the set of the order pair x, comma f of x. Okay? The set A is called the domain of f. So set A is the set of the inputs. Okay, the range of f is the set of all the possible values of f of x, as x varies throughout the domain. So domain is the set of input x, range is the set of output y. Okay, so let's look at example 1. If f of x equals x squared minus 2x, we want to find f of 3x squared and f of p minus 4. So what is f of 3x squared? Well, that means whenever you see x in the expression of f, we replace x by 3x squared. Okay? So 3x squared, we see in the expression, we have x squared. So we place x by 3x squared. And don't forget the parentheses. Without the parentheses, it'll be wrong because you can see now when we try to put the parentheses, we're actually having 3 squared, which is 9. Okay, but if you forgot the parentheses, then we only get like 3. Okay? And minus 2 times x is 3x squared. So I strongly recommend you when you replace by the parentheses and then include the term in the parentheses. Okay, so now let's get rid of the parentheses. 3 squared is 9, and then x squared. Okay, so x to the a to the b, that is x to the, what do you do to the exponent? We multiply. Okay, if we have x to the a times x to the b, what do we do to the exponent? A plus b. Okay, so in this case, 2 times 2 is 4. And then 2 times 3, 6, x squared. So far, so good, everybody? Okay, so f of p minus 4, that means whenever we see x, we place x by parentheses, p minus 4. So don't forget the parentheses. You can imagine parentheses is like your baby. Don't forget your baby in the mall, okay? So we can either leave it like this, or we can also multiply out. Okay, let's try to multiply out and let's see what happens. If we multiply out, well, what is p squared minus 4? Is it p squared minus 16? A lot of students make this mistake, okay? So I really want to remind you again. A plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. And a plus b times a minus b is a squared minus b squared. Okay, so everybody make sure you remember all of those algebra formula. Okay, let's continue. So here we have minus 2ab, so 2 times 4 is 8p, plus 4 squared, 16, minus 2p, and then plus 2 times 4, which is 8. So we combine the line terms. So the highest power is p squared. And then minus 8p minus 2p is minus 10p. 16 plus 8 is 24. So far, so good, everybody? Alright, so let's continue. Example 2, we want to find the domain and range of the following functions. So how do we find the domain? Okay, so I want to remind you there are like 3 types of functions with restricted domain. So what are those? Okay, so 3 types of functions with restricted domain. Okay, what are those? First is square root of a. So what do we need? We need the things inside the square root to be greater or equals to 0, okay? Second, fraction b over a. What do we need? Do we have any constraint on the numerator? No. We only need the denominator cannot be 0, okay? The third one is the natural log. What do we need for it? We need the things inside the natural log to be positive. Okay? Of course, we have other types like tangent, cotangent, secant, cosecant, right? So those stuff we need for tangent, for example, the domain is x is not equals to pi over 2 plus k pi, okay? But those trick functions, when we see them, we kind of remember, okay? But usually, here are the 3 types that we see more common. Okay, let's look at the first example. So we have square roots, right? What do we need? We need the things inside the square root. So this is the things inside the square root. Remember, don't include the square root here. Okay? So the things inside the square root to be greater or equals 0. Okay, when we work with inequality, when we add or subtract a number, it won't change the inequality. When we when we multiply or divide by a positive number, it won't change the inequality. But when we multiply or divide by a negative number, it will flip the inequality. Okay? So here, how do we solve for x? Well, we add x on both sides, and then here we have 2, and on the other hand, we have x. So we have x less than equal to 2. Okay, so I suggest you, when you find the range, draw the real number line, okay, and 2 is here because x is less than equal. So because equal, then you can put a solid dot over there. If it's just less than 2, then you put an open circle at the 2, okay? So less than equal here. So this is our domain, and then when you read from the real line, we have minus infinity and 2. Do you include the 2? Yes. You see the solid circle? So you put a bracket there. So if you want to include the endpoint, you put a bracket. If you want to exclude the endpoint, you put parentheses. Okay? And this is the domain. How do we find the range? Okay, so because of square roots, okay, square roots, can you really reach the 0? Okay, we know square root is greater or equal to 0, but can you really reach the 0? Can x be 2? Yes, can be 2. So that's why the range is 0 to infinity, because you can actually reach the x. When x is 2, then your y is 0. You can actually reach the 0. Okay, and you can see this. I also provided the graph. So this is the graph. You can see our x is less than equal to 2, and then the y is greater equal to 0. Okay? Alright, so let's look at part B. Well, part B, we see square roots, but it's also in the denominator, right? Because it's in the square root, so we need this guy to be greater equal to 0. Because it's in the denominator, we need this guy to be not 0. So when we combine them, well, that means 2 minus x must be greater than 0. Okay, we add x on both sides. Then we have 2 greater than x. Okay, so you see the picture? 2, now we don't include 2, so we put open circle, x less than 2. So it's on the left. You know, the real number line on the left is more negative, on the right is more positive. Okay, so what is the domain in this case? Minus infinity to parentheses. By the way, for the infinity or minus infinity, you always put parentheses because you cannot reach infinity or minus infinity, right? So we put parentheses. How about your how about the range? Okay, you see the square root is greater or equal to 0, but because it's in the denominator, you never get 0. Okay, so this guy, 1 is greater than 0, the bottom is greater than 0, so that the whole thing is greater than 0. So now we can know the range is not include 0, greater than 0 to infinity. And you can see, I provide you the graph of this function, and you can see the domain x is less than 2 and the y is greater than 0. Okay, so in the exam, I won't give you the graph. Okay, so you won't be given the graph, and then what you need is you're gonna follow this 3 type of functions to look at the function, whether it contains those type, and then you find the domain and range. Okay, so let's look at C. To find the domain, we need the things inside the square root to be greater equals 0. But what happened? Well, x squared is always greater equal to 0. So this guy is always true for all x. So that means our domain, x can be anything. So that's why our domain is from minus infinity to positive infinity. Okay, that's the domain. How about the range? Well, the range, we know square root is greater or equal to 0, but what is the smallest number we can get? Well, the smallest number we can get, you know, x squared is greater or equal to 0, right? The smallest number it can get is 0. So that's why we know our y is greater or equal to square root of 0 plus 2, which is square root of 2. So the range is from square root of 2 to positive infinity. Okay? And I also gave you the picture here. You can see square root of 2 is like 1.4 or something, right? So this is the lowest it can get. The domain is all real numbers. The range is greater or equal to square root of 2. So far, so good, everybody. All right. So I want to box this. Okay. Oops. So this is so important. So yes, make sure you remember this, the notes. Okay. Next, vertical line test. A graph represents a function if and only if it passes the vertical line test. Every vertical line intersects the graph at most once. Okay. So, example 3, determine whether the following functions, the following graphs is a function. So we want to check whether it passed through the vertical line test. So for all the vertical line, it can only cross the graph at most once. It can cross it like 0 times or 1 time, but it cannot like more than 1 times. So let's look at the first one. Well, if we draw the vertical line here, it does not intersect, right? But when we draw the vertical line here, see, it intersects 2 points. So if there are some vertical line such that the function, such that the graph cross more than 1 time, then this is not a function. So this is no. So even though maybe you can see at this point it only crosses once, but if there is some vertical line, it crosses more than once, then it's not a function. Let's look at the next one. You see, when I draw this guy, oh, it crosses 2 times, so it's not a function. How about this guy? Well, no matter where I put the vertical line, it's always crossed once. So yes, this is a function. How about this guy? I can put my vertical line here. Well, what happened? It crossed infinitely many times. So infinitely many times. Okay, so entire vertical line consists of that. So this is not a function. Okay, how about this guy? You see, this one crosses once, but even though we put the line here, you see the open circle? It means there's no points there. So this vertical line, it does not cross the graph. So in this case, yes, this is a function. Let me ask you, if my picture is like this, is this a function? No. You see the difference between open circle and solid circle? Open circle means you does not include the endpoints, so you exclude the endpoints. The solid circle means you include the endpoints. Okay? Next. So next you look at, we can put the vertical line here, and then it passes through a lot of points. So this is not a function. And here we can put a vertical line here, so it's not a function. Here we can put a vertical line here, and you can see no matter where I put the vertical line, it only crosses at most once. So yes, this is a function. So far, so good, everybody. Do you have the same answer? All right. Next. Definition. Given two functions f and g, the composite function f composite g is defined by f composite g of x is f of g of x. So it is evaluated in 2 steps. We let u be g of x, so u is like the inner function, and then y is f of u. Okay, so you first compute u is g of x, and then you put your u into the f. Okay, so the domain of f composite g consists of all x in the domain of g, such that the u equals g of x is in the domain of f. Alright, so let's look at example 4. We let f of x be square root of x, and we let g of x be 2 plus 5x minus 3x squared. Part A, we want to find h of x. Okay, let's see. So what is h of x? Well, it's f of g of x. So what does that mean? That means for the x in the expression of f, you replace x by g of x. So we have square root of, replace x by g of x, right? But what is g of x? Well, g of x is 2 plus 5x minus 3x squared. Okay, so this is h of x. So part B, we want to find the domain and range of it. Well, we want to look at whether we have square roots, whether we have fractions, whether we have natural log. Do we have square roots? Yes. Then what do we need? Well, we need the things inside the square roots to be greater or equals to 0. Okay, so see, we get an we get inequality. How do you solve inequality? Okay, so here are the steps of solving inequality. Okay, let me use green color. So I put the notes here. Okay, so how to solve inequality. First, you want to move all the terms on the left hand side. Okay, so that your right hand side is just 0. Okay, and second step, I would say you want to reorder them. So reorder the terms and make sure the leading coefficients is positive. Well, this guy is my habits. I would like to have my leading coefficient to be positive. So in our example here, we have already moved all the terms to the left hand side, right? And we want to reorder them. So we order them, then we have minus 3x squared plus 5x plus 2 greater equals 0. And then I want to make sure the leading coefficient is positive. So what do I do? Because it's negative, we multiply by -1 on both sides. Then we flip everything. So it becomes 3x squared minus 5x minus 2. And we also flip the inequality. It was greater than equal, then now it's less than equals. And 0 times whatever is 0. Okay, so this is the second step. What is the next step? Well, the next step, I want to factor the left hand side. Okay, so I want to factor the left hand side. If I factor it, what do I get? Sorry, I'm gonna change different color a lot because I want to emphasize on the right hand side, those are the common steps. Okay, so when you see a different problem, you're gonna follow exactly the same steps. And then the left hand side is gonna be this specific problems. Okay. Okay, so let's factor it. Okay, so how do we factor it? We can have 3x, x, and then how do we get -5 in the middle? So we can have -2 and plus 1. Then we have -6x and plus x, so we get -5x. I hope that you are familiar with the factoring, okay? Otherwise, please talk to me and I can give you more exercise to practice. Okay? The next step after you factor it, we want to find the critical number. What is the critical number? So the critical number are the numbers make each of your factors 0. So look at the first factor. When you set it equal to 0 and solve for x, what do you get? You get x equals -1/3, right? Second factor, when you set it equal to 0 and you solve for x, you get x equals 2. Okay, so these are the critical numbers. So we find the critical numbers. Okay, and then what do we do next? Okay, we're ready. On the real number line, we're gonna plot the critical numbers. Okay, and if you see less than equal or greater than equal, then you see the equal, then you're gonna put the solid dot at the critical points. If you only see less than or greater than, which means you don't include those critical numbers, then you put the open circle around it. Okay, everybody? And what's next? So let me draw it here. Okay. So the real number line here. Okay, so we're gonna plot the critical number. So minus 1/3 here. 2 is bigger than that, so it's on the right hand side. Then do you see less than equal? So less than equal, which means we include the critical number. So we draw a solid dots at those points. Okay, and then next, there are 2 ways to figure out which region, which subinterval is positive or negative. Method 1. On each of the subinterval. So you can see the real number line separated by the 2 points, so into 3 subintervals. Okay, so on each interval we want to find the sign of whether it's positive or negative for the inequality, right? So let's look at this piece. So this is method 1. We want to plug in numbers in each of the, want to pick numbers from each of the interval and then plug in the inequality to see whether it's positive or negative. So here we can pick the number 3, okay, and we pick the number 3, then we plug in the inequality. So this is the inequality, okay? So you can see, remember we plug in the factor form. We don't plug in here, okay? Don't plug in the general form, plug in the factor form. Because then, see, when you plug in 3 times 3, 9 plus 1, 10. We can see each factor whether it's positive or negative. So the first factor is positive, and the second factor, 3 minus 2, is 1. So it's also positive, right? So that's why we know here, we pick the 3 here, we know it's positive. How about the second factor, how about the second interval? We can plug in 0, right? 0 is in this interval. When we plug in 0, the first factor is 1, the second factor is negative 2, so positive times negative is negative, right? And then how about the left subinterval? We can plug in minus 1, then minus 3 plus 1 minus 2, negative, minus 1 minus 2, negative 3, negative. So negative times negative give us positive. So this is method 1, okay? You can pick a number from each of the subinterval and then plug in the factored form of the inequality to see the sign. Okay, there's method 2. What is method 2? First of all, look at your leading coefficients. If your leading coefficient is positive, then you start with the upper top corner, okay? You stop here, okay? Then when you connect the points, so when you connect the points here, you want to see whether the multiplicity of that number correspond to that root is even or odd. For example, here, what is multiplicity? So multiplicity is the number of copies. So let's say the multiplicity of the root r is the number of copies of the factor x minus r. So x minus r, if you see this number is the multiplicity. Okay, so you can see 2 corresponds to the factor x minus 2. But x minus 2 is to the power of 1. 1 is odd. When it's odd, when the multiplicity is odd, then you cross the x-axis. And then negative 1/3, you can see the multiplicity is 1, is also odd. So when it's odd, then you just cross it. So that's why you can see this is positive, this is negative, and this is positive as well. So far, so good. So this is the second method. And I would say, in general, the second method is easier than the first method because you just look at the multiplicity is odd number or even number, then you can figure out the graph very fast. You don't need to pick a lot of number to plug in. Okay, so let me draw it more. So let me write down what I just said. Okay, so here, if leading coefficient is positive, start with the right upper corner. If the leading coefficient is negative, then we start with any guess. Right, but instead of upper corner, lower corner. Okay, and next, if when you connect those critical number together, so when you cross those points, if multiplicity is odd, what do? We cross the x-axis. If the multiplicity is even, what do? We bounce off. Okay, so cross x-axis like that, bounce off is like that. So far so good, everybody. Alright, so let's come back to our example. What are we looking for? We're looking for less than equal, so less than, or right here. So what is our domain? Our domain is include -1/3 and the 2. Okay, and how about the range? Range, square roots is greater or equal than, but do you actually reach the lowest number? Yes. If x is -1/3 or 2, we get 0. So the range, we actually reach the 0 to infinity. So far, so good, everybody? Okay. So actually, right now, if I give you any factor form of inequality, then you can figure that out, right? For example, if I give you, okay, 3, let's see, let's do 5x minus 2 squared, x plus 1, 7x plus 4 cubed greater than 0. Okay, let's say if we have this inequality. Well, the first one, the critical number is 2/5, and then minus 1, and then this guy is -4/7, right? So you draw the real number line and you plot those points. Oh, the biggest is 2/5, and then -4/7, and then -1, right? So make sure you put it in the good order. The smallest numbers on the left, the largest numbers on the right. Okay, and then because you can see the leading coefficient is positive, so we start with the right upper corner. And then this root, okay, 2/5 corresponds to the first factor, and then multiplicity is 2. So that's why we bounce off. Okay, first of all, sorry, I forgot. Because it's greater than, we don't include those points. Okay, so we bounce off. Okay, so -4/7 correspond to the factor 7x plus 4. The multiplicity is 3, so it's odd, so we cross it. And -1 correspond to the factor x plus 1. The multiplicity is 1, so it's odd, so we cross it. So you can see, we can figure out very easily without here. If you want to use the first method, we have 4 subintervals. And for each of the subinterval, you have to plug in the factors and to see whether it's positive or negative, and it will take more time. So in general, the second method is faster. Okay? Yeah, so we know this is positive, this is positive, this is negative, this is positive. And we are looking for greater than equal to 0. So this piece, and this piece. So how do you write your answer? -infinity to -1, not included. When you have 2 intervals, you use union. So this is union. And then this is -4/7. Don't put positive infinity because you don't have the point 2/5. Okay? So 2/5 to infinity. Yes, be careful. Because we have an open circle at 2/5, you actually need to divide it into 2 subinterval and then union it. So far, so good, everybody? Okay. Here, let's look at even and odd function. So a function f satisfies f of minus x equals f of x for every number x in this domain is called an even function. And a function that satisfies for every number x in this domain, f of minus x equals minus f of x, then we say this is an odd function. Okay, I think this guy should be here. Okay. All right. So we mark any function is either even or odd or neither. Okay. So can you give me an example of even function? The easiest example, x squared, right? Oops. Let me see. Okay, so let's see here the even function. So this is even function x squared. F function is, give me example, is x cubed, right? Neither, in general, let's look at this line, is neither even or odd. Okay, and you can see we have some property, the graphs of even function, they are symmetric with respect to the y-axis. The graph of f function, they are symmetric with respect to the origin. Okay, so you see here, the mirror image across the y-axis is still on the graph. And here you can see this point when you rotate 180 degree about the origin is also on the graph. Okay, so important. Do not confuse even odd functions and even and odd integers. Okay? But they actually have some connection because we know x to the even number is actually an even function. Okay? And x to the odd number, the power functions, is actually an f function. So they have some connection. This is like the connection between them. Okay? Let's look at example 5. Determine whether the following function is even or odd or neither. Alright, so let's see. Okay, let's call this guy is f of x. So we want to check whether they're even or odd function. We compute f of minus x. So that means whenever you see x, we place x by minus x in the expression. And don't forget your baby parentheses. So minus x to the 4th, and then minus x squared 2 times minus x. Okay, what is minus x to the 4th? Well, that is just x to the 4th. What is minus x squared? Well, that's just x squared. And cosine. Well, do you know what a cosine? So cosine graph looks like this. So you can see cosine is symmetric about the y-axis. So cosine is an even function. So when you have an even function, negative, just ignore it. Okay? And also, do you know what is sine? Well, the sine picture is this. It's oscillating between -1 and 1, okay? And you can see the sine is actually a f function. Okay, so now let's come back to this example. You can see, woo, this is the same as f of x. So now we know f is an even function. So if f of minus x equals f of x, then the function is even. Second, so part B. Okay, so part B, let's say this is g of x. Then what is g of, so what is g of negative x? Well, that is sine 2 negative x cubed. Okay, so negative x cubed, cube is a f function. So that's the same as negative 2x cubed. And then because sine is also an f function, so you can move the negative outside. Alright, so you can see, oh, this is minus g of x. Okay, so because g of minus x equals minus g of x, so then g is an odd function. So far, so good, everybody? How about part C? Well, if we call this as h, well then h of minus x equals 5 times minus x minus 2. Let's multiply by 5, so we get minus 5x minus 2. Okay, what is this guy? Is this equal to 5x minus 2? Of course not. And this is actually, we can fetch out the minus. We get 5x plus 2. And for the absolute value, the minus can cancel. So we have absolute value for 5x plus 2. So we can see they are not equal. Well, is this guy equals to negative absolute value of 5x minus 2? No. This guy is always positive. And this guy is negative, right? It's less than equal to 0. This guy is greater or equal to 0, okay? So that's why h of x is not equal to h of x and is not equal to minus h of x. So that's why h is neither even nor odd. Okay, everybody? So here, I also want to summarize some rules with you. Okay, so what are the rules? So here, I want to use green color. Is this green now? Okay. So, composite function of even and even function is even. Okay? Composite of even, odd and odd function is actually odd. Well, composites of even and odd function is actually even. Okay? For example, even, you can think about x squared. So x squared and square is x to the 4th. It's still an even function, right? Odd and odd. Oh, x cubed and cube is x to the 3 times 3, not 3 plus 3, okay? 3 times 3 is 9. It's still odd, so it's still an odd function. But composite of even and odd function, or composite of odd and even function, well, you can see now it's x to the 6. So this is the even function. So, an analogy is you can think of like the blood type, okay? The blood type analogy, okay? So, blood type. You know, like O is actually II, right? A type is like AA, but AI is also type A. Okay, everybody? So you can think about like the odd function is like the I. odd function, we get odd function. But even function is like the A. AI is still A type. AA is still A type. So the even function is like really dominant. Okay? Alright. So that is the theory about odd functions and even functions. So let's continue in part B. We're going to talk about the graph of some common functions. Okay? So we'll see you in part B.